for Sealed Air Corporation of Massachusetts by Mohr Corporation. Mohr is spelled M-O-H-R, in Detroit, Michigan. The press in the middle of the screen is a Courtoy Rotary powder compacting press, frequently called a tablet press. It's the very same press in principle as is used to press aspirin tablets or other pharmaceuticals or food products like candies. In this case, we're pressing the powder that you supplied to us that you needed to consolidate powder into a denser mass. We've taken this press from our large inventory of second-hand machinery and put it under power here in our Detroit, Michigan facility. We have returned to you with this videotape sample parts that have been tableted on this press. And remember that the size and shape of the tablet is determined by tooling. The tooling in this case was previously used for pressing tungsten carbide metal tire studs for snow tires, and therefore is not necessarily representative of the tooling that you might use or the next owner might use for their particular product. The depth or thickness of the part is determined by the amount of adjustment on the powder fill depth. And in this case, we have not used all of that mechanism's adjustment and could have increased the powder fill depth. Since we had no experience with your powder, and since you could not provide us with pressure parameters, we simply set up the press, putting your powder in the powder feed system, pressing your parts, so that we got a dense mass, which we can make more or less dense, and with a change of tooling, we can change the entire shape and size of the part. Arrived to us in this box. In the center of it is just a drink carton that we've used to scoop it into the press. We've made no attempts to try to keep the purity aspects of your powder, if in fact it was pure in any way. Placed into this stainless steel powder hopper, which is mounted above the rotating table. I'm going to elevate the camera so you can see the inside. By gravity, and in this case, we do have an air vibrator mounted to the hopper that I'm pointing to right now. The powder travels down onto the die table. That's referred to as a die table on the rotary press, where it sits inside of the feed frame. The feed frame is the part that I'm pointing to at the moment. The press so that you can see how the punches go up and down as the press rotates. These upper, and there are lower punches you can't see, punches are following cams or a cam track, which makes them go up or down at the appropriate point to move away from the die to allow filling to take place, or in the case of the upper punch to come down for compaction, the bottom punch to drop at the appropriate time, such as when it's underneath the powder feed frame to allow powder to fill the die, and then to come up to eject the part. Now as the table rotates, in this case rotating in a counterclockwise position, it's moving in the direction that my finger is moving, and as you saw before, powder fill begins at the position that you see right now in the center of the screen. Under the large casting that you see in the back is where there is a roller that forces the punches down, and here you can see the cam is bringing the punches down. Ultimately, it comes underneath the roller. You can see the end of the roller right there. That's just a freewheeling roller, which provides the pressure of the punches on the powder. And we have an adjustment here which allows us to increase or decrease the pressure on that punch. I'm going to go to the other side of the press right now. Opposite side of the press, you can see the hand wheel, which through a worm and drive mechanism causes that roller to go down or up mechanically, which forces those punches further or not as far into the die cavity. And as the punches come back around in this direction from underneath that compression roller, you can see they're going up. That's because the upper punch is moving away to clear the powder feed tube, and the lower punch is following a track bringing it up so that it's ejecting the parts, which are going to hit that mechanical part right there and slide down this trough where we are collecting them inside of this cardboard box. Perhaps not very scientific, but hopefully it's doing the job of showing you what this press would be capable of doing, or the concept of the press, since we handle so many presses of this type. Looking at the portion just before ejection, and I hope using the macro you get a little better close-up view of the tooling. Here you can see a punch sticking down on the end of the punch holder. What you see below the punches are the opening into the die. In this case, the lower punch being slightly down from the flush position where it would be an eject. And there is the upper punch, a corresponding lower punch, and the dies are held in by the set screws through here. Again, your part is deflected on that plate and drops away as the punches move further around to get underneath the powder feed shoe. We're going to turn the press on. You may find that this will go a little bit in and out of focus periodically for just a moment. That's only because I'm trying to get a macro view of the ejector showing the parts coming off of the press. So bear with me, this is an informal tape made for you only. So just a moment, please. The eject position, and we're starting the press up. You can see the press moving around and how rapidly it's moving. And the parts are hitting that deflector and coming down this trough as press compacts. You can see them bouncing off at this point. That's the lip of the container. Now, we're not running this press at maximum speed at all. If we want to remember this, we're at number 4 on the Reeves variable speed drive motor located in the back. We'll try and get a better reading once we have the powder out of here. We've expressed a little concern about using this press even in the manner that we're doing it. We normally don't do this kind of test work without some formal arrangement, compensation, etc., gentlemen or ladies. We're very pleased to be doing this for you, but bear in mind that this is not a very scientific test, but nonetheless, hopefully will move you further towards your goal. This press has 22 individual stations. Rotary presses can be made with many more or less stations. And this, again, is a Belgian-built Courtoy. It's considered among, if not the most precise rotary press manufactured for industry anywhere in the world. And here in the United States, generally, it is the type of press used for very precision powder compaction. In this case, the tooling is extremely tight-fitting tooling. And your press, your powders would actually benefit by much looser tooling. In this case, the upper and lower punches are made of very precision tungsten carbide, as is the die, or at least an insert in the die. And for your powders, we would probably recommend hardened tool steel with considerably looser tool tolerance, which would allow powder feeding to happen much faster and your parts to be straight-sided rather than the draft that you're probably seeing on them at this time. Just to give you a brief view, this plant is filled with new and second-hand, the majority of it's second-hand machinery. In this case, this happens to be a machine assembly and rebuilding bay. The section of the plant, this is machinery warehousing, powder presses, powder blenders, and mixers. That's our mainstay. That happens to be a single-station tablet press right in front of you. And I'll take a closer-up view of that in just a moment. But we are primarily known at Mohr Corporation not for metalworking machine tools and metal stamping presses. We're powder process people, from mixing and blending to powder compaction. You may not know the difference in a single station versus a rotary tablet press. This is a view of a single station press leaving here very shortly this afternoon. The stainless steel powder hopper is where the powder goes in to feed into the feed shoe in the center of the screen, which swivels over the hole that you see in the center of a die table right there where the die is mounted. An upper punch is here. A lower punch would not be visible but would be in the bottom. Powder feeding occurs. Then the upper punch moves down when the powder feed shoe has moved away. Then the upper punch lifts away as the lower punch ejects the part. The powder feed shoe sweeps back over to fill once again, at which time it sweeps the part away for ejection. Hydraulic and mechanically operated single-station powder compacting presses. The disadvantage compared to a rotary is that when powder filling is occurring, nothing else is. The same with compaction, the same with ejection. Speeds on a press like this might approximate at maximum output 60 tablets or parts per minute, whereas on a rotary press it can be hundreds if not thousands a minute. Speaking of output, you have a box of parts, and we were running this press at approximately 6 pounds, plus or minus, probably it would be a little bit more than that, per hour basis, as I mentioned. We can increase that speed rather dramatically, output out of a single station press, even with multiple cavities in a single station press. In this presentation with a final view of the Courtoy rotary press, and And we'll look forward to your further contact concerning this project. And do keep in mind that we handle piston and auger extruders as second-hand or new machinery. We work with many different methods of forming. We're doing this work on a rotary press because after seeing samples of your powder, it appears to be far more appropriate than briquetting machines or pelletizing machines of the extrusion type. I think this is really the best direction for you to take on your project. Mohr Corporation is at area code 313-846-3000 or 1-800-223-MOHR. Our fax is 313-846-3766. And we thank you very much for the opportunity to work with you and for viewing this entire presentation. That does end this presentation.